Hi, welcome to In and Around Computer. In this video, we are going to see the types of switching mode. In the previous video, we have seen the switching techniques where the switching techniques will choose the best route to forward the packets in the networks. In this video, we are going to see the switching modes. That is, the switching technique is achieved by using the switches where these switches can operate in three modes. So different modes are used for forwarding the packets known as the switching modes, and that is the switch can operate in three modes, that is store and forward, cut through, and the fragment free. So these are the three modes where the switch can operate while forwarding the packets in the networks. In any switching mode, the parts of the frame header of a packet or frame is analyzed. That is, whichever mode the switch operates, the parts of the frame header of a packet or a frame is analyzed. We already know the data is split into packets while the transmission during the networks, and a frame contains the following parts according to the IEEE 802.3 standards. So the frame or a packet will have the following parts, that is a header and start frame delimiter, data, and the frame check sequence. And the header will again has four fields, that is preamble, destination, source, and the type. That is, this we can see in detail, that is what and all is there in the frame header or and the various parts of the frame. This frame header will have four fields, that is a preamble, destination, source address, and the type. That is, frame header is the part which contains the basic information about the frame, such as the preamble, that is a sequence of a stream of ones and zeros that provides the synchronization of packets or frames. And this destination address is the destination MAC address where the packet has to be delivered, and the source address, this is the MAC address of the system from where the packet originated. So, and the type is the type of Ethernet protocol being used for communication. And next part of the frame is, according to the standard, is the start frame delimiter, that is 1 byte data. It is the starting point of the packet, and the data is the data being transferred in the packet. It is generally around 46 to 1500 bytes long. And the frame check sequence, that is or FCS, this contains a 4 byte long cyclic redundancy check to check for the corrupted data. So these are all the parts of the frame, and now we can move to the various switching modes. The first mode of switch is the store and forward switching. In this mode, the switches store the entire frame to check for errors before forwarding it to the next node or destination. That is, the switch waits until the entire frame has been received. Once received, the switch stores the frame into its memory buffer, and this is the storing stage of the process. And once stored, the frame is checked for any existing errors, and if an error is found, and the entire frame is discarded, else the frame is passed to the next node. So this is the forwarding stage of the process. This can be better understood by this particular animation. And here the node PC1, that is PC1 is sending the data, where the PC1 calculates the CRC value of the frame and inserts it in the FCS field, and the switch stores the frame and calculates the CRC value, and it again checks with the FCS field, and if it matches, then it would be considered as there are no errors and the packets are forwarded. And in this case it is matching, and so the frame was received, we can say the frame was received with no errors, and hence the packet is forwarded. And so this is the about the store and forward mode of switching. And Next mode of the switch is the cut-through switching. Here the frames are forwarded the moment destination address is resolved. That is, there is no waiting for the remaining segments of the frame. We can say that is, once the frame reception has been initiated, the switch waits for the first 6 bytes following the preamble. The destination address is then looked up so that the destination address is got, that is, the destination address is then looked up in the switching table. From this table, the switch determines the outgoing interface ports to interact with the destination system. Once the destination and the ports are identified, the switch forwards the incoming frame to the next node. So this can be understood by this animation where this PC1 is sending data to the PC2, and where that is frame load, in the sense that is the data. As soon as the destination MAC is received, the switch makes a MAC lookup, and if it and forwards the frame, that is, it makes a MAC lookup, and if the match is found for the destination MAC address and destination port is got, then the uh, frame is forwarded as soon as the destination address is resolved. And due to the absence of error checking, the destination can be compromised by corrupted or tampered data. So this is a disadvantage of this cut-through switching mode. And next is the fragment-free switching. Here, the switches operating in this mode must receive and examine the first 64 bytes of the frame and then make up the forwarding decision. In an Ethernet LAN, the collision fragments are detected in the first 64 bytes. So, this mode of switching determines detects the colliding frames from the first 64 bytes, and once the frame reception has been initiated, the switch checks at least for the first 64 bytes of the frame, that is 7 bytes of preamble, 6 bytes of destination MAC address, 6 bytes of source MAC address, and 2 bytes of Ethernet protocol type, 1 byte of start frame delimiter, and at least first 42 bytes of data being sent to the destination. So since 64 bytes is a significant amount of frame, and if there were some form of overlapping, this chances of collision will be detected. That would be that is, overlapping will be detected in the first 64 bytes. And if a colliding frame is detected, then it is discarded. Otherwise, the frame will be forwarded to the next node. And these switching modes differ in how much of the frame, that is, how much bytes of frame must be received and examined by the switch before the start of frame being forwarded out from the port. So this is the standard frame format, that is that we already said, and this frame load is nothing but the data, and the that is three modes of switching is differentiated by the way how much of the bytes have to be received before the forwarding of the frame starts from the particular port. And in the cut through switching, after the preamble, 6 bytes have to be received, that is, this destination MAC address has to be resolved. So the 6 from after the preamble, 6 bytes have to be received, and once the 6 bytes are received, the forwarding starts in the cut through mode. And in the fragment free mode, 64 bytes have to be received, that is after the preamble, destination MAC address, that 6 bytes, and the source MAC address, that will have the 6 bytes, and totally that will have the 12 plus 2 14, and after 14 some till 14 to 64 bytes of the data have to be received, so that if there is an overlapping frame, then that will be detected in this mode. So still 64 bytes have to be received before the forwarding starts. And in the store and forward mode, the entire bytes, that is the full bytes of frame must be received, and then the forwarding is started out from the port. So these are the differences based on the number of bytes that has to be received before the forwarding takes place in the three modes of switching. So subscribe to my channel if you feel contented, like and share my videos with your friends.